Hello class, this is the notes we're gonna take during today's class. I'm sorry I had to be gone. Your notes should have been given out for chapter 3. It looks like this, chapter 3 notes. We're going to be covering part of it today, and I'm going to probably have to change your homework a little bit for tomorrow, but it won't be terribly different. So I'm going to talk you through this, and then you'll be doing your seat work. You will all need your calculators out for this lesson as well. Measuring in units. Measurement is the act of comparing an unknown quantity to a standard unit. It consists of a number and a unit. The standard unit would be something that we all agree on. So one example would be a total, or if I told you that a total was this long, okay? And so everybody would say, okay, from now on, if I ever need something called a total, it'd be from here, this length. And then I could measure how many tottles across is the paper. And I would just take the exact same length and move it across the paper. So I can't do that here, but I would just call this amount a total. And then say, how many tottles wide is the paper? And I could approximately say, oh, a little bit more than 3 tottles wide. So it's a standard unit that we would just all agree that length is a tottle. Another example would be we could agree that a length is a student, and we can measure the length of the hallway by laying the student down and then moving him up until we see how many students long the hallway is. Dimension. There you go. Oh, I got to get the pen back. Okay. A dimension is a quantity of a system that we can measure, like length or volume or time or charge or let's see, width, other things like that. Collaborated is when you take a scale and it's accurately subdivided into measurements. And so calibrated. We calibrate instruments so that everybody's instruments read the same thing. If I want to know the temperature, I want to make sure that my thermometer is reading the temperature in the exact same way that your thermometer is reading it. Otherwise, we may get different temperature readings. Now, how to calibrate a Celsius thermometer. If you look in the Prezi for this chapter, Prezi for chapter 3, which I would normally be using in class, it has a great picture for how to draw and calibrate a Celsius thermometer. I'm going to do it really quickly here, and I want you to fill this in your notes. So what you'll have is a beaker, and this beaker has ice water in it. These are my ice cubes or little flecks of ice, and a thermometer without any kind of markings on it. And that thermometer, the liquid inside that thermometer, is going to rise to a certain point. And in this is ice water or freezing water. Okay? When it rises to this point, we're going to mark that point on our thermometer right here as 0 degrees Celsius. So that's the first fiducial point. Now we're going to take our thermometer out and let it get to room temperature, and we're going to put in a thermometer in a different thing. Now what I do is I put the thermometer in some boiling water. So the water is moving around fast. This is boiling water now. And the reason I let it sit out in room temperature is because if we change something from cold to hot or hot to cold too quickly, it will shatter. So we have to let the glass kind of go back to room temperature. And so again, this is boiling water. This was freezing water over here. This is the second fiducial point. We put our thermometer down into the boiling water. We have our liquid that had gone up a certain amount at freezing. Well, now because of thermal expansion, because when things get hot, they expand. You should have talked about that a little bit in physical science. So this expands up. The liquid gets hotter and hotter, and it goes higher and higher in the thermometer. And when it stops going high, when it reaches its maximum point, we mark that point as well. And that point would be 100 degrees Celsius. Now we should have is one thermometer rather, and on that one thermometer we have a marking down here somewhere that's 0 degrees Celsius, and we have a marking up here somewhere that's 100 degrees Celsius. And now all I do is I just divide them all. Divide it up into 100 pieces, or divide up the scale evenly. And that's how you calibrate a Celsius thermometer. All right, now like I said, if you go look at the Prezi, there's a really nice, neat picture of all of this, and you should be able to copy this down. You need to know this and copy this down into your notes. I will be looking for these pictures in your notes. All right, the metric system is based on units of 10. In the modern metric system, called the SI metric system, or System International, whatever, was adopted in 1960. Now, I marked out on here the things that you do not have to know yet. You do not have to know current. The amount of matter is a mole, and we're going to cover moles super well by the time we get to Chapter 9. So the things I want you to know right now are length, mass, time, and temperature. All right. For length, if I'm measuring length, I'm going to be measuring it in meters, and so I need to know that a meter has a symbol of an M. If I'm measuring mass, I'm going to be measured in kilograms or grams. I will take both. And if it's kilograms, it's kg. If it's grams, it's g. And the reason I say that, and you'll see it a little bit more in a few minutes, I like to use the units without prefixes. For time, we're going to be measuring in seconds, and the symbol is an S. So you got to know the name of the unit and its symbol. You must know all of these. And then for temperature, kelvins, and the unit is a K. Now, from all of these units, you can derive mathematically all the other units we need to know. Now, let's look at this. This picture is also in your notes. From this picture, you're going to need, it's really important that you learn the prefixes, like yada. That's interesting. We're not going to need to know yada, but I just thought that was cool. Yada, septillion. Now I know what a yada is. The ones I want you to know, though, start with giga right here and go down through nano. So you have to know all of these in this area. You have to memorize all of these in this area. Okay, so a gigabyte or a gigameter would be a billion meters. A mega would be a million. I'd say mega million. Mega million. That's how I remember that. Mega million. A kilo, which you should be very familiar with, is 1,000. Now look, also notice you can see what exponent all these are brought up to. Hecto is 100. Deca is 10. Like a decade is 10 years. Deci is a tenth, or 10 to the minus 1. Centi is 100th. Milli is 1,000th. And then micro is a millionth. So mega million, micro millionth. And nano 9, that's how I remember that one. Nano is a billionth, and it has a 9 in it, 10 to the minus 9. So you need to know these prefixes. There's the ones again listed on your notes that you need to know right here. And this right here is a mnemonic device. And we're using it so that we can, the spaces are there on purpose. We're going to use it to help us to memorize the order of these prefixes, and we're going to use moving our decimal place right or left based on these. But we're going to do bridge notation first. This is going to be our check, but it is important for you to memorize this. Now notice up here again that giga was 10 to the 9th. So a giga anything, like a gigagram, would be 10 to the 9th grams. This space holds the 10 to the 8th space. This is the 10 to the 7th space. A megagram would be 10 to the 6th. And this holds the 10 to the 5th, 10 to the 4th. This king is for kilo, and kilo is 10 to the 3rd. Sorry, 10 to the 3rd. H is for hecto, which would be 10 squared, or this is 10 to the 1st. Deca, like Ucky, is 10 to the 0. Remember, anything to the 0 power is equal to 1. The Ucky stands for unit. And the basic units are grams, meters, liters, all the things without prefix in the front. So the unit section has no prefix in the front. Then the D, the dark here, is for deci, which is 10 to the minus 1. The C is for centi, which is 10 to the minus 2. The M is for milli, which is 10 to the minus 3. Then we have two spots held again, minus 4, minus 5. 10 to the minus 6 is micro, minus 7. Sorry, that looks nasty. Minus 8, and 10 to the minus 9. So you see that there's a spot for each place. Now the way that we memorize this is we go gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk, space space micro space space nano. Now we say that to a rhythm, and we're going to say it over and over again for a few minutes here, and it helps us to be able to memorize all of this from the beginning all the way to the end so that we can write it quickly. Gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk, space space micro space space nano, gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk, space space micro space space nano. I want you to practice that at home so that you can write it really quickly. What I want you to be able to do is write G for gigaspace space, megaspace space, King Henry drank Ucky, and then I usually like to use lowercase letters for the small ones, dark chocolate milk, space space micro space space nano. And I usually write the word micro because milli and micro both start with a lowercase m. So gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk, space space micro space space nano. Now the other things that you must know are these things here. 60 minutes is an hour, 60 seconds is a minute, 1,000 meters is a kilometer. Kilo means 1,000. A meter is a little bit bigger than a yard. 1,000 milliliters is a liter. Your 2-liter bottle would have 2,000 milliliters in it. So a milliliter is really, really small. You must know these. 1 kilogram is 1,000 grams. I will not put these on the test. You must know these by heart. Now, unit conversion is the process. This is the process. And it consists of multiplying a measurement by a conversion factor. And a conversion factor is a tool that you use. Here's some examples of some conversion factors. Now, 1,000 milliliters and 1 liter are exactly the same thing. If I had a container and it contained 1,000 milliliters and had a container on the bottom and it contained 1 liter, it would contain the exact same amount of stuff. So what is it when you when you divide something by something that's equal to it? That's equal to 1. So this is really just equal to 1. It's exact same volume. So that means I could put the 1 liter on the top and the 1,000 milliliters on the bottom. It's still a conversion factor equal to 1. 1,000 grams and 1 kilogram are also the exact same mass. If I had a scale and I put 1,000 kilograms, 1,000 grams on this side of the scale and 1 kilogram on this side of the scale, it would be balanced, exactly the same mass. So this is also equal to 1. And that means I could put the kilogram on the top and the gram on the bottom if I need to. 60 minutes is an hour, so 1 hour is also 60 minutes. These are equal to each other. 60 seconds is a minute, and so the other one that I could have made would be what? What do you think? Well, 1 minute is the same thing as 60 seconds. All of these guys are conversion factors. Now what we're going to do is use bridge notation to calculate these right down here. And I want you to use bridge notation when you're doing this work. You can use the gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk as a test or as a check for yourself. So I'm going to write that here. Gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk, space space micro space space nano. I want you to be able to write this out without thinking. I may even do a pop quiz or pop bonus and say, okay, do this right now. And then if you can do it and turn it into me, I might give you a point. So, excuse me. So let's try this first one. Bridge notation. I know that some of you may have learned it differently or just use a different kind of notation, but you need to learn bridge notation because it is pretty standard in doing chemistry. Okay, so we're going to start off with 132,540 centimeters and draw the bridge. This is the support for my bridge. Now, I have to turn centimeters into kilometers. So let's look over here. This is where the centimeter spot is. And this is where the kilometer spot is. Whenever you go from one side to the other, this is hard to do on this thing, you got to go through the base unit and then to the other unit. So this is going to be a two-step process. Okay, so I'm going to change first centimeters into the base unit, and the base unit for this in this case is meters. So in this case we're going to go from centimeters to meters, and then from meters to kilometers. From centimeters to the base unit of meters, and then from meters to kilometers. So we got to put, now notice centimeters is on the top. That means it needs to also be on the bottom, and I'm changing into meters first, so meters goes on the top. And so what is the relationship between these two guys? Well, centi means 100. There are 100 centimeters in a meter, just like there's 100 pennies in a dollar, or 100 cents in a dollar. So 100 centimeters in a meter. So put the 100, just leave it in blue, 100 down here, and 1. Now we have a centimeters in the numerator and the unit for centimeters in the denominator. You should be able to kind of draw a diagonal line and cross those guys out, top to bottom, top to bottom. Numerator, denominator are canceling. You cancel units just like you do numbers. So if I'm going to do my math right now, I'd say 132,540 divided by 100, and I would have a number, and that would be in meters. But my question is asking me to turn it into kilometers. So make my bridge a little longer, one more support, and I'm going to change meters into kilometers, that is. So kilometers is what I want, so that needs to be at the top. Meters is what I got to get rid of, that has to be at the bottom. So what is the relationship? Well, kilo means 1,000 meters. So a kilometer, 1 kilometer is 1,000 meters. And you go back again, circle your unit. You don't have to circle them. I'm just doing this for teaching purposes, but you just have to cancel them. But I'm showing you that they're showing up in the numerator and in the denominator. Numerator, denominator. So these two lines help me to point out it has to go from top to bottom. Now, put all this in your calculator, and you should get a number, and that number should be in kilometers. Okay, so the number we should get now, once I put it in the calculator, would be 132,540 divided by 100, and divide a second time by 1,000. And don't multiply these guys together. You'll cause it, what you'll end up doing is you'll say this divided by that, and you multiply it by 1,000, your number will be wrong. Take this divided by 100 and divide again by 1,000. And the answer is 1.3254 kilometers. All right, now I'm going to show you how that works by using a check over here. So let me erase for just a second. All right, back to a pen. All right, again, I went from centimeters to kilometers. So I moved from centimeters 1, 2, 3, 4, 5 spaces to the left. So if I write my original number, or here's my original number, and move it 5 spaces to the left, the decimal's at the very end. 1, 2, 3, 4, 5 spaces. The decimal needs to now be right there. So it should be 1.3254. And that's what I have. So I use this as a check, 1.3254, not 0, as a check for my answer up here. Now let's try another one. This time we have 350 milligrams to kilograms. So erase this line. Go back. Okay, 350 milligrams is right here, and kilograms is right here. So I got to go back through the unit and back to the new one. So always if I go from one side to the other, this way or this way, I have to go through the base unit. And the base unit in this case is grams, because we're talking about grams with no prefix in the front. So I'm going to start off writing, using bridge notation, 350 milligrams, and draw the bridge and the support. What's the relationship? What are we doing actually? We're going from milligrams to the base unit of grams, from the base unit to the next unit of kilograms. So I'm going to go from milligrams to grams. So grams has to be at the top and milligrams has to be at the bottom. Okay, and then what's the relationship? How many milligrams are in a gram? Well, there are 1,000 milligrams in a gram. That's one of those units you have to know. Like here, 1,000 grams in a kilogram, 1,000 milliliters in a liter, or 1,000 milligrams in a gram. Same thing. 1,000 milligrams in 1 gram. All right. So notice numerator, denominator. I can cancel out those units. Okay. You don't have to draw this line. I'm just showing you. I'm trying to put it in your brain. Numerator, denominator. Okay. Now, if we did our math, it would be in grams. I'd say 350 divided by 1,000. But I got to go from grams to kilograms next. So kilograms goes on top, grams goes on bottom. What's the relationship here? The relationship between kilograms and grams is right here. Okay? And this time the kilograms is on top, so we need 1 gram, and there are 1,000 grams in 1 kilogram, rather. Again, numerator, denominator, same. That means I can cancel out the units. The only uncanceled unit is a kilogram, which is what I'm going to need. Now I want you to notice when you get done, I would prefer that you circle your answers. It makes it easier for me to locate it. All right, so now I put all this in the calculator. It should be 350 divided by 1,000, divide again by 1,000. Do not multiply these guys together. 350 divided by 1,000, divided by 1,000 again, and that answer should come out in your calculator to be something like this. It might say 3.5 e negative 4. All right. This is a calculator answer. It is not the correct way to write it, and if you write your answers this way, you will not get full credit. This e negative 4 means times 10 and to the negative 4 power. It means the exponent is a negative 4. That's what it means. The exponent is a negative 4. So the correct way to write it would be 3.5 times 10 to the minus 4. And kilograms is the only unit that did not get canceled. All right, so now I'm going to use my gigaspace space, megaspace space, King Henry drank Ugly Dark chocolate milk. Space, space, micro, space, space, nano. I'm going to use that to check my work. I'm going to put it up here because I'm running out of space. So 350. Here's where the decimal would go. How many places do I need to move it? Well, going from milligram to kilogram, I'd go 1, 2, 3, 4, 5, 6 spaces to the left. So here's my decimal. Let's move it. 1, 2, 3, 4, 5, 6 spaces to the left. I write the decimal, then add the zeros in the little valley areas. So there's my number, and the end decimal would go away. So this is my new number right here. All right. But this is not the best way to write the number, so we need to turn this one back into scientific notation. So now we're going to move the decimal to right to this spot. In scientific notation, you need only one number to the left of the decimal. So 1, 2, 3, 4. You need only one number to the left of the decimal. So we'd write 3.5. There's one number right there. And then times 10 to what power? Well, I moved it 4 spaces, but I got to know if my exponent is positive or negative. If I'm changing a number that is less than 1, if my number is less than 1, then I'm going to have a negative sign. If my number is greater than 1, sorry, that's the wrong way to do that. And really, this one too. I wrote that wrong. If my number is less than 1, then write a negative sign. If my number is greater than 1, you're going to write a positive. So if this number right here, 0.00035, is definitely less than 1, so the exponent is a negative number. Okay? So that shows me that I got the right answer right here. Okay, let's do another one. 670.7 nanometers to meters. Okay, let's go back up here and see what we're moving from. We're going from nanometers to meters. Okay, nano, there it is, way down here. I'm going from nanometers all the way to meters. Okay, I'm not going to the other side past the basic unit. The basic unit here is a meter. So nanometers to meters is just a one-step process. So meter, I need 1 meter at the top, I need nanometers at the bottom, and I need to know how many nanometers are in 1 meter. Well, a nanometer is 1/billionth of a meter, so that means it takes a billion of them, or 10 to the 9 of them, to make a meter. Go back up. Look at this right here. Here's nano. A nanometer is that tiny. That's 1/billionth, a billionth. So it's, or another way of saying a billionth is 10 to the minus 9. So if it's this small, then it takes 1 billion of them to make a meter. Just like a centimeter is 1/100th of a meter. So that means it takes 100 of them to make a meter. Just like a penny is 100th of a dollar. So it takes 100 pennies to make a dollar. So this right here is showing you what size it is compared to the meter. If it takes a billion, 1/billionth is a meter. If a nanometer is 1/billionth of a meter, then it takes a billion of them to make a meter. So 10 to the 9. Now you can write it 10 to the 9, but you could also write it as 1 billion. It takes 1 billion nanometers to make 1 meter. Either one of these is okay. This is just shorter. Okay, so now you can see that the units are going to cancel. And so we have meters left. So we have to put in our calculators to get this number. Now the way to put it in your calculator, you should pull out your TI-83 or better calculator. The way to put it in there would be to write 670.7 and then divided by 1 second function EE, and the EE button is right where the comma is, 9, and then enter. 1 second function, that big yellow second function button is what it looks like on my calculator, it might be different on yours. EE 9, enter, and it should give you this number. 6.707 times 10 to the negative 7. Now your calculator would have said 6.707 e negative 7. Remember, this e negative 7 really means the exponent is a negative 7. All right, there's your answer. And we can check it by checking, seeing how many places I had to move here. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. We moved 9 places. I'm going to go ahead and just use the decimal right. There's the decimal. We have to move 9 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And we'd put the new decimal right there, and we'd fill the zeros in right there. But because that's really hard number to write, we need to put it in scientific notation. So we move the decimal from here, which is, this number is definitely less than 1, so our exponent should be negative, and we move it back to right in this spot because scientific notation has 1 number to the left of the decimal. So we go 1, 2, 3, 4, 5, 6, 7. I moved it 7 places, or 6.707 times 10. This number was less than 1, so 10 to the negative 7, which is what I got right here. All right, we're going to do one more, and then you're going to do the seat work down here. I would like for you all to, you should have enough time to completely finish the seat work. And then I have a video that you're going to watch tomorrow where I work these out plus you see the answers, and the video will also have the accuracy and percent error and precision versus accuracy, and these little pictures right here, and that'll be the end. We're going to start significant figures on Friday. So I'm going to update your homework just a smidge, so make sure you go back and check it, and I'll send an email about that too. So let's do this last one. Megagrams to milligrams. All right, I got to erase a little bit of work down here so we can see. Megagrams to milligrams. All right, there's the mega, and there's the milli. So we're going to have to go through the base unit one more time, and we're going to go from megagrams to the base unit, from the base unit to milligrams. Then we're going to do our bridge notation. So 0.0043 megagrams. Draw your bridge. Put the support up. We got to go from megagrams to grams, and then from grams to milligrams. This is one time when the capitalization is super important. That should be a capital M. That looks pretty awful, but should be a capital M. So megagrams to grams. So grams goes on top, and megagrams has to go on the bottom because it's in the numerator. I need it in the denominator. I need to be able to cancel it out. So what's the relationship between megagrams and grams? Mega million, mega million, mega million, mega million. So there are 1,000,000 grams in a megagram. A megagram is huge. Think about like the Mega Million lottery, which, you know, I don't condone. But anyway, mega million. 1,000,000 grams in a megagram. You could write out 1,000,000 if you wanted to. That's fine. Or you could do 10 to the 6th, because that means the same thing. So now, numerator, denominator. The units in the numerator and the denominator, there's a 1 right there, they cancel out. Or you could draw the diagonal line if you wanted to see that they're gone. One numerator, one denominator. If I did my math right now, I'd say 0.0043 times, this is multiplication on the top, times 1,000,000. But that won't give me the right answer. I need the answer in milligrams. So I got to draw a little bit more bridge and another support. Now the reason we're learning to do this, even though these are just moving our decimal places back and forth, is we're going to come to a point in chemistry where we're going to do bridge notation, and we're going to change grams into moles, and moles into other moles, and those moles into particle counts, or anything, and you're not going to be able to move decimal places. You can only use unit conversion to be able to do the math. So you need to understand and practice bridge notation, and it is imperative that you show all your work. A correct answer with no work does not get any credit. So hear that. A correct answer with no work gets no credit. All right, now milligrams is what I need. So milligrams goes on top, grams goes on the bottom. And what's the relationship between a milligram and a gram? Milli, like a milliliter, is 1 liter. 1,000 milliliters is 1 liter. 1,000 milligrams is 1 gram. 1,000 millimeters is 1 meter. So 1,000 goes on the bottom for this one. Okay, now you're gonna multiply the top together, and you're going to divide the bottom. So when I do that, I'm going to go point here. I'll pull up my calculator right over here. Whoops. There it is. I got to move it so we can see. Turn it on. All right. We would say 0.0043, and then I'm going to multiply that by 1,000,000, and then I'm going to divide that by 1,000. Enter. And I got 4.3. That's not right. That calculator something's weird on this calculator, because that should be 4.3 times 10 to the 6th. Okay, so obviously I made a mistake somewhere. Do you see it? I see it. I see it right now. Right here. This is a mistake. There's 1,000 milligrams in a gram, not 1,000 grams in a milligram. Put that number in the wrong spot. Going to totally get the wrong answer. So let's go up here and erase this and put it back. You probably were all shouting at me in your heads, Miss Graham, that's wrong. Well, now I realize it. This is one reason I show my work. Okay. So now 1,000 milligrams in 1 gram, just like 1,000 milliliters in 1 liter. I just wrote the number in the wrong spot. Now we can do the canceling. The grams and the grams. They cancel out. And now, instead of dividing over here, we're going to be multiplying on the top twice. So we're not dividing, we're multiplying. Let's pull that calculator back up. Scoot it over. And do the math. Turn the button on. Okay. So 0.0043 times a million, 1, 1, 2, 3, 1, 2, 3, and times again 1,000, 1, 1, 2, 3, enter. There we go. There's your number, 4,300,000. Okay? So 4,300,000 milligrams. Now that's a really big number, so I'm going to turn it into scientific notation. So the decimals at the very end, and I need to move it to right here. So there's only one number to the left of the decimal. So 1, 2, 3, 4, 5, 6 places. I'm moving the decimal 6 places to the left. So it's 4.3 times 10 to the positive 6 milligrams. Because this number, 4,300,000, is much bigger than 1, so the exponent on the 10 is positive. Okay, now we've done all these. We could go ahead and practice. We could go ahead and check this number by using the line up here. So mega to milli. So we're going to move our decimal place. We're going from megagrams to milligrams. 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right. So here was my original number, 0.0043, and we move it 6 places to the right. Let's use a different color just for the fun of it. 1, 2, 3, 4, 5. That's not right. Mega to milli. 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right. I don't know what I did. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right. Fill in the zeros. And you would see right here I have 4, 3, and then 6 zeros. 1, 2, 3, 4, 2, 3. 4,300,000, which is what I had before. All right, I know this was kind of difficult to follow. I appreciate you hanging in there. I didn't have time to do this more than once. So good luck. I want you to sit now and do the seat practice, and I will see you on Friday, Lord willing.